Hi there. I hope you're doing well on this beautiful day. What is today's focus on our lesson? We want to focus on statistics, but the focus will be on correlation and data. Okay, so have a pen and paper with you there, and remember how we do mathematics. We don't just observe, we need a pen and paper, and we need to think, question what is happening there, okay? And take your notes. It's not about observing only. Let's see what we have today. Hope you're ready. Now, under statistics, before we look at that, what I'd like you to think is how do we predict the change to dollar-rand exchange rate? How can we really predict? Let's say the rand today to a dollar is about 14 rand to a dollar. How can we predict in the next 2 months how much will rand be trading against the dollar? What do we use to do that? Okay, and why should I do that? I might be traveling in future, and do I exchange my currency now or do I exchange in future? We know at some point the rand was approximately 17 rand to dollar, and I think at the moment it's a bit stronger to about 14 rand, and that fluctuates with time. Okay, so if we have lots of data meaning information, and we can put that on a scatter plot, we can kind of see the trend, and one can use different kind of models to predict what does the rand look like in future. So one will use data to predict the exchange rate in future for the rand against the dollar. Okay, fantastic. I hope that makes sense. Okay, good. And if you have time, I'd like you to look at the trend, okay? If you have your device, just look at what is the rand today to the dollar, and look at what it was 3 weeks ago, and what do you think would look like in 3 weeks' time? Okay, take your time and use a device if you have something like that, and look at the trend. Fantastic. So let's see, what is machine learning? Have you heard of something called machine learning? Okay, do you know what is machine learning? Have you been on YouTube and you'll watch a video? After watching a video, then it will recommend another video. You say, oh, because you watched this, therefore, the next one is this. That's kind of like a machine learning, because it kind of predict what you like in a way. What are the other machine learning? Some insurance company will put a device, something in your car, and they kind of study how you drive, and they'll reduce your insurance premium, how you pay per month, based on the data they collect. Okay, it's kind of like data that kind of predict the future in a way. Does that make sense? Something of that nature, this machine learning. Let's look at, so what are we going to look under our statistics? We're going to look at, let's go back there, we're going to look at Univariate Data, Bivariate Data, correlation, and scatter plot. We're going to look at the 4 concepts and what does that look like. Okay. Before we do that, some keywords I'd like us to look at that. What is correlation? And what is data? What do you think correlation is? Okay. What do you think data is? We already defined what is data by looking at machine learning. Okay, that machine learning, it can kind of collect lots of data and predict what will happen. An example was more like a YouTube. You watch a video. By watching this, and it'll predict, oh, the next video you like is this one. Okay, so data is information. But correlation will talk about 2 variables. I can talk about your maths marks and science marks. Does it mean if I get a good maths mark, I'll do well in science? Do those 2 things move together? Does that make sense? Okay. Another way to think of correlation, is the petrol price. Okay. why does the petrol price go up and why does the petrol price go down? Why? Because there is a correlation between the petrol price and the oil price. Usually, if the oil price goes up, the petrol price goes up. Similarly, if the oil price drops, the petrol price goes down. So the two correlate. Can you think of something else of correlation? We can think about interest rates. Have you heard about interest rate? Usually, if interest rate goes up, if you have money in the bank, your capital goes up. But if you have lots of credit or debt, if interest rates go up, the money, you have more in debt. Are we together? There's so many correlation exists in many, many ways. But don't confuse something called correlation and causation. Okay, does that make sense? What do I mean when I say causation? Let's assume today is so hot and we're at the beach and lots of people are swimming at the beach and some people drown at the beach. But on that day, the sale of ice cream was high. Can we say because the sale of ice cream was high, therefore ice cream caused drowning? No. So we mustn't confuse correlation and causation. Okay, fantastic. I hope correlation makes sense to you. Think of two variables that correlates. How many hours I spend studying and the results I get. I think there's some correlation. Okay, fantastic. Now let's look at an independent variable and dependent variable. When we talk about the independent variable, it's a variable that does not depend on the other variable. Okay? If I look at Cartesian plane, that will be my x-axis. That will be an independent variable. Where dependent variable depends on the other variable, so that will be the y. Okay? And to get that y, my input must be the independent variable. Okay? Hope it makes sense, guys. Our independent and dependent variable is just my x and my y value on Cartesian plane. Okay? Fantastic. Beautiful. So we will look at statistics. We said we'll look at univariate data, Bivariate data, correlation, and scatter plot. We'll finish with scatter plot. Let's look at univariate data. What is univariate data? Univariate data is a data concerned with a single variable, okay? So it's a single variable, just single one variable. I'll give an example. A simple example of univariate data will be the salaries of workers. Let's look at this in an industry. So univariate data would be a data of this nature. This is the industry. We talk about agriculture and food industry. So the average monthly salary is 17,000. Okay, so that's a single data point for this sector of the industry. Arts and culture, we know that in arts and culture, the average salary is about 18,000. Okay? In banking, the average salary will be about 26,000. And customer support, 17,000. And also we can see information technology, 31,000. Insurance sector is 25,000. Education, approximately 19. Those are just average. It's just univariate data, tells out the industry and one single point. That's our univariate data. Okay. Then what about bivariate data? So bivariate data will differ from our univariate data. How does it differ? So the bivariate data has two measurements associated with it. For example, if you're studying a group of students, you want to study a group of students to find out their average mathematics and physical science marks. You have two variables. So it's by. By, we're talking about two. Univariate, talking about single. Okay. So this will be bivariate data. What do we have here? We have students' mathematics marks and physical science marks. And we might be interested in, does it mean a high maths mark means a good physical science mark? So we want to plot the 2 points and see what is happening. So if you look at this, what does this mean? So this is maths and this is physical science. So a student who gets approximately 80% in maths gets 79% in science. Okay? We're talking about 2 bivariate data and 50%, 44% physical science, 56% in maths. That implies about 60% in physical science, 67 mathematics, about 70% physical science, 85% for maths, 81 physical science, and 93, 88, 45%, which is 33% for physical science. By looking at this data, what do you see? Okay, what can we conclude from that? I mean, hence we might have to do some analysis or sketch a scatter plot. Based on this, can I conclude a high maths mark implies a high physical science mark? Does it mean if I perform poorly in maths, I'll perform poorly in physical science? If you look at this, I mean, this is 45% for physical science, which ends up to 33%. But we have one data point. Can we really conclude based on that? So usually we need like lots of data to make an informed decision, okay? And later we'll explore more and calculating even correlation, look at that. Okay. Okay, guys, we are going to take a short break. And when we come back, we'll explore more on correlation and looking at some of the statistics. I hope you're ready and everything's going well, and keep working hard, and remember to have a pen and paper when you do your mathematics. And it's okay to struggle. It's okay as long as you're doing something, okay? And continuously you work on your mathematics. Okay, fantastic. See you shortly. Hello out there, welcome back once again. We are looking at correlation and data, okay? So remember, your pen and paper, you work hard. It's okay to be challenged when you do mathematics, but what is important is continuous hard work. Even though you don't understand anything, you keep working hard every day. I mean, you don't wait for a challenge to start doing your mathematics, okay? I can promise you, continuously, if you can do an hour, you won't see those challenges. Because most of our challenges, what we try to do, 2 days before a test or a big exam, we want to cram everything. That's impossible. You have to work on continuous basis. Okay. So let's see what we have under correlation. So now we said we'll focus on correlation. And we did define what is correlation. Remember correlation, we talk about association between two variables in this context. I give an example of what? Oil price and petrol. Those two there's a strong association between those two variables. Okay. Usually if petrol price goes down, it's because of the oil price. Are we all together? Something of that nature. So think of other variables that are associated, meaning correlated or with correlation. Okay. So let's see what we have now. So we can use a scatter plot to show whether there is an association or correlation. I've used the word association and correlation. Interchanging the two means exactly the same thing. Association, associated, correlations, just exactly the same thing. And remember, what is a scatter plot? Okay? A scatter plot, if I take my Cartesian plane in the first quadrant and I put all the coordinates, okay, my dependent and independent variable, that is my scatter plot, okay? We'll look at an example at a later stage. So let's see what we have. So if points on a scatter plot, so we're talking about points. When we talk about points, we're talking about independent and dependent variable. So it's the coordinate, which is x, y, okay? So we put those coordinates, we kind of have a table. And we put all our coordinates, okay? And if you look at the trend, we can kind of guess our correlation. Okay, let's see. See, if the points on a scatter plot are roughly in a straight line, we say the variables are correlated, So let's see what is that. So something like this. So there we have our points. You can see our points there. But if we draw a straight line, which we have there, our points are scattered close to the straight line. Are we together? So we say now there's a strong association between the x and y. And remember, x could be anything. It could be petrol price, and this could be the oil price. Okay? This is independent variable, and that is our dependent variable. Strong positive, and very important, why do we say positive correlation? It's a strong positive correlation. Okay? I'll come back to that. The strong positive correlation. So when we talk about positive, if you look at the straight line, you know, the equation of a straight line, you can think of something like that, which is y equals to mx plus c. If you remember that. So m is the slope or the gradient, okay? This does not mean this is the equation of a line. Just give you an example. So if the gradient is positive, your line is going up. If m is bigger than 0, positive, that's if m is positive. And if m is smaller than 0, which is negative, your line is going down. So we say positive correlation going up. What does positive correlation mean? Implies the independent variable and dependent variable, they move up together or down together. That makes sense? If oil price goes up, petrol price goes up. Are we together? Another way we can think of positive correlation, the more hours I do my maths marks, I increase my hours, my results go up. Positive correlation. Are we together? Are we together? Can we think of something with negative correlation? One goes up, one goes down. Have you heard of something called inflation? If inflation goes up, the value of the money goes down. So those are negative correlated. Okay. So this is a positive correlation. So let's look at a weak positive correlation. So the points are more scattered but follow a general upwards trend. So let's look at that. So there it is. I mean, yes, the points are not scattered like compared to the first one, close to the line. But yeah, they're roughly scattered around the line. So we say this is a weak positive correlation. What does a weak positive correlation mean? Can you think of something? I'll say Yeah. The more hours I sleep, will my maths marks improve? Versus the more hours I study, my marks will improve. More hours I study my maths, marks will improve. There is an association. But the more I sleep, will my marks improve? There is an association, but which is stronger? The strongest, I think, is the more I study, the more I will perform better. Because I could sleep, but not doing my maths. Doesn't mean it's associated. So it's weak correlation. But also, I can't study so many hours and not sleep because that can impact on my results. Which here, can you think of something with weak positive correlation? My positive correlation moves together. Okay? I increase how many hours I study, then what happens? My results increase also. Let's look at that now. So a negative, strong negative correlation looks like that. The points lie close to the straight line with a negative gradient. Remember, a negative gradient, it's a slope. So if you draw a line, that's what we get. So a negative correlation, points lie close to a straight line with a negative gradient. What is a negative? What is different? What does a negative correlation mean? It goes down together. Are we together? I don't study anymore. I reduce the hours I spend on my maths. My results goes down. The oil price goes down. The petrol price goes down. Are we together? The negative correlation? Are we together? Okay, great. So, what about a weak negative correlation? The points are more scattered but follow a general downward trend. So there's a negative weak correlation. We can see we have a straight line there. The points, those are some of the points, okay? Negative, we can draw a straight line with a negative gradient, and the points are slightly closer to the straight line. Hence, we can conclude a weak negative correlation or association. Okay, fantastic. Now, what about no correlation at all? So no correlation, the points are scattered across the graph, indicating no relationship between the two variables. There's no relationship. Can I draw a line then? I cannot draw a line. Can you think of two variables with no correlation? It's like no association between them. Can you think of any? Okay? I'm trying to think of something with no association between the two. Okay? So, how about, I can't think of any now. Okay, if something comes up, I'll come back. There's no relationship between the two variables. Okay? I mean, let's say if I eat bread every day, will I do well at maths? Is there a relationship between that? Okay? Maybe. But I don't think there's correlation between that. Okay? Okay? Good. So, there's no. So correlation is a measure of relationship, okay? But we spoke about the two variables, relationship meaning association. The stronger the correlation, or the association, the more closely related the variables are likely to be, okay? The correlation coefficient, so we call this correlation coefficient, lies between -1 and 1. This can also be written as this. So this implies the correlation coefficient is between -1 and 1. What does this mean? We can quantify, we can measure correlation. And correlation is from -1 to +1. If correlation is 1, we say perfect correlation. If correlation is -1, it's a perfect negative correlation. Are we together? So because this is from -1 to 1. I mean, in between there we have what? 0. Are we together? I mean, 0.5 would be somewhere there. I mean, -0.5. Positive 0.5 there. So what does that mean? This is perfect correlation, which is 1, and this is negative perfect. No correlation there. So this is positive 0.5. So this is a weak, okay? And this is a weak positive, and this will be weak negative correlation, okay? Are we together? What about 0.1? 0.1 will be very weak positive correlation. Are we all together? So correlation can be measured, and the value is between -1 and 1. And at later stage, we'll look at how can we really calculate this correlation and get a number. And from there, we can make some conclusion. Okay, let's look what we have now. So we agree that correlation is between -1 and 1. This implies just using inequalities, correlation is between -1 and 1. What does that mean? If someone says, my correlation is 2, oh, that does not make sense. Because correlation is between -1 and 1. If someone comes and says correlation is 0.5, yes. Correlation 0.5. 0.5, it's between -1 and 1. Are we together? It cannot be something bigger than 1 or something smaller than -2. It's impossible. It's between -1 and 1. That's correlation. So what do we say? We say if R is 1, R is 1, it implies this indicates a perfect positive linear correlation, association. I'm able to draw a perfect straight line. If I do that, that's a perfect association. Are we together? So those two variables are, we're 100% sure that they are strongly associated if R is equals to 1. Okay? Positive linear correlation. What about -1? So -1 also, you can see that our point's going down, but we can draw a straight line going through all the points on our scatter plot. So that's a perfect negative correlation. Are we together? One goes up, one goes down. Okay? Positive correlation, going up, together. Are we together? And zero correlation is quite difficult to draw a line of best fit. I can't draw a best line of fit. One can say, okay, there, okay, but that's not really perfect. Okay, are we all together? So now, what do we say? Positive correlation, two variables moves together. One goes up, the other goes up. Negative correlation, one goes up, the other goes down. Zero correlation, no association. Yes, we're interested in two variables that have no association. We also want variables that something goes up, something goes down. We spoke about what is that? Inflation. If inflation goes up, I cannot spend more money. My money in my pocket goes down. But positive correlation, one goes up and one goes up also. Okay, fantastic, guys. I hope this makes sense. And We'll come back, see you after the break, and look at more statistics. And remember to keep working hard and pushing hard. What is most important with the mathematics or anything is consistency. Consistency is the ability to study every day. If you say, every Tuesday I'm doing this, you wake up and do it, even when conditions are difficult. That's consistency. That's how you get better. Consistency is very important. See you after the break with more statistics. Hello out there. Welcome back once again. We are still on statistics, and I hope you're enjoying out there and you're working hard. And remember, consistency is the key. Okay, so what are we going to look at now? In this segment, we're going to look at what? Our scatter plot. What is a scatter plot? Have you seen a scatter plot before? Okay, it's a scatter plot with just representation of data of an independent and dependent variable, which is x and y coordinate in the first quadrant of our Cartesian plane. Okay, that's how we're going to draw our scatter plot. Okay, let's see how we do that. So there's a scatter plot. So here I have size and weight or mass, okay, of a person. So that's the shoe size and how much they weigh. So the data was collected, okay? So as a survey implies, we went to people, what is the shoe size and what is the weight? Found that the shoe size was 5 and the weight was 65 kilograms. And shoe size was 12 and weight 97. And another person, shoe size, which was 7, weight 68. Another person also you can see there was shoe size 10, weight 92, and so on. By looking at this, can you say, is there a correlation between shoe size and weight? Think about this. Okay? Size 5, 65 kilograms. But also look at that. Size 6, 74 kilograms. Okay. Let's see how. How do we represent this on a scatter plot? So we're going to start with 5 and 65. Size, which is shoe size there, as independent on the x-axis, and mass in kilogram as dependent variable on the y-axis. You can see that. And remember to choose your scale, especially if you're not given a place where you draw your scatter plot, okay? Scale is very important, okay? So where this would be my x and this would be my y, okay? So let's see what we do with this. So 5, if x is 5, y is 65. Then I put that as a point. Are we together? On my Cartesian plane. Let's look at the second point. When x is 12, what is y? 97. So we have 12. 12 is there. We have 12. And 97 is between 195. Okay? 12 and 97. There's the point there. Okay? So we already have 2 points. Based on this, can I say, is there a correlation? Can you see with 2 points, I cannot really make a conclusion because I can draw a straight line passing through those 2 points. But can I conclude that, is there a correlation between size and mass? That's why it's the importance of having a large data before you make a conclusion. Because with 2 points, I can draw a straight line. And for me to conclude that there is a positive, a strong correlation, That's not really good. With large data, we actually make better, we get better results. Okay, let's look at the third point. So shoe size is 7 and mass 68. So the shoe size is 7, 68. 68 is between 65 and 70. Okay, let's see what we get. There's the point there. We have 3 points now on our scatter plot. With 3 points, is there, what kind of correlation with 3 points? Is it a good thing to use 3 points? No, because with 3 points, that we can get misleading results. We need more data. That looks fairly like strong positive correlation. Okay, if I assume 3 points. But let's put more points. Size 10, mass 92. This is what do we get for size 10 and 92. If you go back, we get 92. So now I'll put all the points, 10 and 78, 9, 78, the same thing, 8, 76. If I put all the points on my Cartesian plane, let's see what we get. This is, what do we get? All the points represented. This is our scatter plot. Okay. If you look at our scatter plot, what can you conclude about the correlation? Is this a negative correlation? Definitely not a negative correlation. I cannot say there's a negative correlation because points going, I can draw a straight line with a positive gradient. A negative correlation if I draw a straight line with a negative gradient, okay, slope. By looking at this, okay, so can you estimate the value of correlation? Remember we said correlation is between -1 and 1, where 1 is perfect, positive, -1 is perfect, negative correlation. I would say this is strong positive, close to 1, maybe 0.8, okay? Are we together, guys? I hope this makes sense. Now, what are we going to do, guys? I would like us to play with the simulator. What is simulation? Have you heard of the word called simulation? Let's look at what this looks like. Let's see what we have here. So we have our x-axis, independent variable, y-axis, and the correlation coefficient. So simulation will depict the reality. Let's look at what reality we want to depict here. So let's look at height versus shoe size. Height versus shoe size, the data looks like that. So this is the shoe size and this is the height. So we can see that the points are close together. If we draw a straight line through those points, okay, we can see we're going to get what? A positive gradient. Let me see that. We're going to get a positive gradient. I can try something like that. This is my y value. You can see that. And this is the gradient. Let's move there, somewhere there. And this is my something of that nature. Okay, not perfect. But by looking at that, can you guess the correlation coefficient? Is it a strong correlation? Correlation, we know, is from -1 to 1. What is the value for the correlation for that? I think it's, should I say 0.5, 0.6? Let's see, what does this give us? It gives us actually 0.85. It's actually strong positive association between the height and the shoe size. Okay, does that make sense? Great. Let's look at our own simulation, which we're going to do. So let's look at that. Here, what I want to do, I'm going to take points, put them on a Cartesian plane. Okay, look at what is happening to the correlation coefficient value. Okay, let's look at that. It's getting smaller. Why is this getting smaller? Okay, let's look at that. I'm putting more points on the Cartesian plane. Great. Is there correlation here? Definitely. There's no correlation. And if you look at the value, the correlation is 0.114. It's close to 0. Remember that zero correlation is no correlation. So this is a weak correlation. Are we all together? It's a weak correlation between that. Even if I have to draw a line, I mean, can I draw a line? It's quite difficult to find a straight line for that, you know. I mean, if I do that, you know, it's quite, I can't find one actually, sure, for that. But what if I want to increase the correlation for these 2 points? What can I do? Actually, let's see if we move. Look at, I'd like you to focus on the correlation. Now is 0.26. I'm moving the points together, close together. Look at that. Look at that. What is happening? Let's look at that. Let's look at it. Now it's 0.5. Look at that value. Moving this, 0.99. That's actually strong correlation, because for perfect has to be 1. But by moving this, what is this point? Look at this 1 point. How can this point change the value of correlation? All the lines, all the points, they can actually form a straight line. But we only have 1 point there. That point, let's look at this point, which I'm moving around. And this is actually making the correlation to be close to 0. What do we call this point? It's an outlier. Look at the impact on a correlation. So huge. This is 0.18 by 1 outlier. Let's move this back together. Let's move it somewhere there. Nice, 0.99. I can get a nice straight line. Let's look at this. I can get a nice straight line with a positive gradient. That's my straight line. We can see that there's a strong positive correlation, which I can get from there. Okay, guys, hope this makes sense. Okay, and for us to get a perfect correlation, what must happen? Actually, all the points, they must be on a straight line. Let's see if we can get this close to 1. If I move this there, move that point on the line, move that point on the line, move that point on the line. This is on the line. I'm moving this. Okay. If I move that, not changing, still 0.99, 0.99, 0.99. Let's move this one. Okay, actually quite difficult to do that. Okay, let's see. So I have to move this. Yeah, almost. Look at that. I'm getting RS1, which is a perfect correlation. Okay, but I can see there's still 1 exactly not on the line, but I'm getting a perfect correlation. Okay, fantastic, guys. I hope this makes sense and you really understand what is happening here. Okay, so now what we have looked at, we've looked at univariate data, we looked at Bivariate data, we looked at correlation, and we looked at the scatter plot. Okay, I hope this makes sense and you really understand. Okay, then from there we looked at our statistics, and this is the concept we looked today. Okay, I hope you enjoyed. Okay, this is the end of our lesson, and we hope to see you soon. And remember to keep working hard. Okay, we hope this makes sense. Okay, you keep working hard, take your textbooks, try some of the problem, read a little bit about correlation and this scatter plot. And we hope to see you soon, and enjoy.